As we continue to learn more about genomic data in healthcare, I'm pleased to welcome our next speaker, Professor Markus Perola, who is leading the quantitative genetics group in the public health research team at the Finnish Institute of Health and Welfare in Finland. He is also the Chief Scientific Officer of the Finnish Institute of Health and Welfare Biobank and a participant and active member of several large international genetic consortium studies. Today, Dr. Perola will tell you about returning polygenic risk scores for biobank participants using a web-based interactive tool. So, hello, Professor Markus.
Can you hear me?
Yeah, so the floor is yours.
Thank you. It's a pleasure to be with you, although I'm not picking a lot of the Latvian I've been hearing, but anyway, it's always fun to tell what we are doing here in Helsinki. So I'm a professor in the Finnish Institute for Health and Welfare. I do genetic epidemiology, and we have some years ago started the project on piloting the return of polygenic the genetic data to the biobank participants. And here I'm going to tell you a little bit how the things started and how they are now going. So we call this P5 study, or P5 in health study. P5 comes from the P4 medicine and then population health on top of it. And we do these population-based cohort studies every 5 years in our institute as a part of our law-abiding duty to help monitor the health of Finnish people, and that gives us also a nice cohort to study as a bonus. And we had the last study 2017, and actually we are now doing our second study after that. It's 2023. We are a year late because of some administrative changes here. But anyway, these are the original FinHealth 2017 was recalled by us the next year for this genetic study to study how individuals perceive and handle information on genetic risk, and how does this information influence their health-related behavior, and is interest-based. And we especially wanted to try whether it's ethical and practical and pragmatic to use this kind of internet-based portal to return the information on genetic risk. As you know, there are regulations on how to translate information to people on genetic risk. There have to be a pre-consult and post-consult, and but it's not specified whether this should be done in person or not. And we presumed, our hypothesis was that this is good enough for this kind of polygenic risk scores. We chose 3 common diseases to study, and there were coronary heart disease, type 2 diabetes, and venous thrombosis. And on the right, you can see how it went. So we first re-invited all these 6,500 people who had participated in 2017 study. About 3,500 of them agreed to participate. Then we sent them re-consent for this study and a questionnaire. Then we had already at the original study collected DNA from them and had the polygenic risk scores also performed, and then we combined this data with their personal data like lifestyle, etc. And then we gave them the results through our OMA P5 website, which is like own P5 website, and then we are following them now up through questionnaire studies, and next one will be this spring, for example. And I will show you some results now about this first questionnaires and how the study went. I want to emphasize that the study was not meant to follow up on the endpoints. We do follow up them for cardiovascular and diabetes endpoints, but we realized from the early beginning that this is not big enough study to monitor how this kind of information will affect their perception of cardiovascular risk in that way that they would really change their behavior. So we would see it in endpoints. There was just not enough people. This was mainly a pilot study for a larger study that is under planning. So what kind of feedback did we give them? So we worked together with our public relations and communications department and tried to factor out these kind of things that people would understand how to this kind of sometimes complex information would be perceived best. And so we gave them separately for each disease general information about the disease and the lifestyle. And then we calculated 10-year disease risk given traditional risk factors and genetic risk. And also they got both like this traditional risk factor estimate and then the genetic risk combined to that. And also the genetic risk as itself. How it is today and how it would be in age 60 if they were under 60 years of age at the recruitment. And we did not give them only the polygenic risk score, but also single clinical variants related to these diseases. Mainly for coronary heart disease, we screened for the most common familial hypercholesterolemia mutations and for venous thrombosis for factor V Leiden and antithrombin mutation. So how did we get the information? So that was entirely to my P5 portal. So we have in Finland the government made Suomi.fi, Suomi is Finland in Finnish, Suomi.fi system, so where we can securely by two-way identification to sign in. People use this a lot for like bank purposes and for reviewing their electronic health record data and to get their prescriptions to renew. So this is quite familiar for all of us. However, the average age of people participating was 55. So there was a lot of elderly people, and some of them requested paper results mainly for that they didn't have this kind of a banking info, and for example, for some old people, their partners or younger relatives handle their banking business, so they couldn't get this kind of information. But only 50 did that. All the others were okay with it. And remember, we had 3,500 people participating. This is a snapshot of the study. They were in Finnish, in Swedish, which is the second official language in Finland. We have to have it as government institute, and of course we're glad to do that. It's quite easy actually, these translations nowadays, and then we had that also in English for the few people who did not speak both, and they were designed by graphic artists in our institute, and we tried to, or we actually have to pay attention to the accessibility here. It's a law also that as government regulators we have to have multiple access ways to this data, and there were like these sub pages that we told them about the study, about these 3 diseases, about polygenic risk score, what does it mean. We actually have a video on YouTube on that as well, but that's on Finnish, so I'm not going to show it, and Swedish. The something about lifestyle, which is something that they can do themselves to affect their risk. Then something about heredity and genes, and when to see a physician, and that was important for us. for them to first of all realize that even most results, they don't need to go to see a physician. So I'm pretty sure people working on this field mostly know this, but I'll describe a little bit what is a polygenic risk score. When we do a genome-wide scan on a given phenotype, anything, we get a lot of different loci that signal for association with the given disease. We can use that information to capture all the variation in the genome that predisposes for a disease, like here was coronary heart disease, diabetes, and venous thrombosis. Of course, that's different for each of these diseases. And it's different for all of us. So each of us, identical twins excluded, will have a different polygenic risk score to given disease. And the important thing about this is where do your personal risk lie as compared to the others, how big that is, and how of course for the total risk it's important to know these also other traditional risk factors. And it's actually pretty easy to calculate if you have the knowledge to use the most common statistical softwares in genetics nowadays, and it's very much used. One problem about that is that it's for clinical use, at least it's not really well standardized how you do it, that there are different methods to doing that, and that this is something that needs to be resolved before it's widely applied. So how did we show the genetic risks? So, for example, we had several graphical ways. First, we had this in a written format, and then we tried to enlighten the view. For example, this person who was for type 2 diabetes in highest risk group, and then we had like tailored. This was automatically formed. Coded system, so it gave actually their actual polygenic risk score and the actual percent, and this was kind of tailor-made for each disease and each person. We also had the chance to give some information about the single clinical relevant variants. This was just very pragmatic thinking of the physicians participating in the study. That it's if you have one of these high impact variants, the polygenic risk score is usually dominated by them, or actually it's not really useful in many cases. Well, there is some information it might be useful, but anyway, this information is even more useful. And actually for these we had a clinical geneticist who telephoned all the few people who had these, all but the factor V Leiden and prothrombin, there were more than 1,000 people, and we thought that this risk is something that can be communicated through internet. We did call, or she did call, all the ones that were homozygote for factor 2 Leiden. I think there were like 2 people like that. We tried to graphically make the perception of the risk easier. We used this thermometer system where the particular personal risk would be, and this was mirrored by this kind of population-based view that shows that in her case, this person means that 8 people out of 100 would get the disease in next 10 years. So this is important, in our way to put these risks in context that laymen understand. As usual, the risk for the disease was quite low in general. There was not so many people with high risk, as you can see for here. This is actual data. We stratified this in 10-year age groups, the participants from 24 to 75 years of age, and as we can see, the risk increases by age as it should, but however, the general distribution was always quite low, and of course there are a lot of outliers even in the young age group. As always, age and sex are most deterministic of these traditional risk factors. We also wanted to tell them what kind of issues would happen if they would change their lifestyle. For example, here they see that, okay, given their current risk with their lifestyle would be almost 8%, but if they would go behave like the average people in this person's age group, the risk would be like half of that, and how his risk would increase at 60. So this was again tailor-made for each person, automatically using our coded algorithms, and these were like visually inspected by one of our two of our poor scientists before giving to them. We also adapted. This is kind of a familiar thing for us in our institute, because our institute has been holding the FinRisk risk calculator for coronary heart disease for a long time, for about 20 years, using traditional risk factors. This is borrowed from that with permission. I'm actually in FinRisk steering group, so it was easy to get the permission. So they could actually change their risk with the interactive risk calculator. They could see that what the risk would be like in 45 if they would quit smoking and etc. So they could play around with their risk, and this has been shown to was quite popular among these people, and we hope that it encourages them to change their lifestyle. This is an important issue. So I'm a practicing physician myself, and when we were planning this study, I was worried that I would get like 6,500 or thousands of angry phone calls from the doctors of these people if they would go and complain about the results or consult about the results, and what have you been telling my patients. So we collected a clinical group. Actually, we were pretty lucky to get like many key opinion leaders in these given diseases in Finland for these groups. Everybody was very excited, and we made these risk-based letters that given the total risk and genetic risk of people, well, if they go to the doctor, they could print out the PDF or show it from their cell phone and tell the doctor that this is something that I was told that you should read, because most of the physicians, GPs, don't really know a lot about these issues, so they would be as confused as anyone with this kind of thing. And we were actually, there were very few contacts because of clinical issues back to us from either the participants nor doctors. So about 3,500 participated, and it was 54%. It was a bit of a disappointment because these had participated already in a year before. But anyway, the distribution was surprisingly similar with the original sample. So we couldn't see, for example, that younger people would participate more than the older people for the genetic part either. So this was a bit surprise to me, but also a bit reassuring, so we could make comparisons between the cohorts. We asked them about this, how their general knowledge about genetics is. This was pretty common. This has been used in many Finnish sociogenetic studies, and they knew pretty well how things go. The blue one is the right answers, and we were happy about the people really in Finland know pretty well how these issues are. We invited about 3,000 people to participate. We were a bit disappointed that about 600 of them did not go for the portal at all, about 20%, but this is free thing and people are busy and we couldn't see any inclination on who would not visit the portal or who did. The one thing that we wanted to monitor was that how often they need to call us back. We had a phone number and an email that they could call for problems. We got only about 100 contacts, 67 by phone or 47 by email. It was in most cases technical and only 11 cases medical. All the medical issues were consulted from the nurse who answered the phone by three physicians, all at consultant level, and one of them was clinical geneticist. The response rate for questionnaires was 71% before the release of genetic results, but only 42% after. So after they got these results, many of them got tired of the study, I guess, and got what they wanted from it, their risk scores. However, the results were not too hard to understand for most of the people, but of course 20% of the people say that yes, this is something that we have to think about in the future. We also contacted the participants came from 50 different primary healthcare districts. I sent a personal letter to each chief physician on these healthcare districts, and we asked whether these had contacted the health centers. We got astonishing 88% response rate. This is very good from doctors. If any have studied doctors, this is very surprisingly high. And in most health centers, no participant had made contact about. So we don't think that this really burdens the healthcare as sometimes is thought. So we gave more to more than 3,000 Finns feedback on the genetic risk of 3 common diseases. The information does not seem to produce unnecessary worry on the participants in general, nor large burden on the healthcare. And most of the participants did not find the portal information hard to understand. And we are now following it up to volunteers for 5 years by e-questionnaires and national health registers, mainly to see how their perception of the risk evolves and whether they have been. We also monitor how often they visit the website. So this is a pilot study utilizing genomic information in healthcare, and we plan to utilize this information if and when we get funding for a larger study on the same subject. Thank you.
Thank you very much, Professor Markus Perola. Now I would like to ask, to give an opportunity to our audience to ask you up to 3 to 5 questions. So in case if you have questions, dear listeners, you can use either this microphone or microphones here. Professor Markus Perola will see you, and you won't see him.
Okay, let me ask a question. Hi, Markus. Thank you for participating, and it's very interesting to hear your lecture because we also planning the similar studies here, and so it would be very good to learn from your knowledge. My question is probably that this technical thing on the precision. I know that the population is quite heterogeneous in Finland, including all these different populations and so on. Does it somehow affected the way you calculated or adjusted the I don't know, first of all imputation and then also the risk score calculation, or at the moment it's kind of general one?
Thank you. So very good question and very timely. No, we did not do this separately for different ethnic or national groups. the thing is that we invite for the original study 10,000 people, which are like, there's no, we don't select for like being a Finn or anything like that. If you have a social security number, you may participate, and we are happy about that. However, we see often that many immigrant background people don't participate in these studies. This is actually a problem we are working with the whole larger study, and also in this genetic study, even less participated. So we had actually very few people, but for them, we gave specific information that this is calculated based on European data, and this might not be so accurate for them for the genetic part. So we didn't have we didn't have even kind of a background material to do their own polygenic risk scores for them, sadly.
Okay, thank you.
So are there any other questions? Seems that not at the moment. In case if we will get some questions, we will send them to you, Professor Markus Perola. And thank you very much one more time for your presentation.
Thanks. For last thing, I want to say that if you're really planning your own personal or national study on this, I'm happy to share these kind of a doctor's notes for you if you want. So just email me.
Mm-hmm. Okay. Yeah. Thank you.